Good evening, Titans. This is Mr. Simpson, and tonight we're going to be discussing direct variation, which comes from section 5.3 in our book. So, what is it, and how do I know when I see direct variation? First, the definition. If y varies directly as x, that means that the equation is y is equal to k times x, where k is the constant of variation. K would be the rate of change. Do you see any similarities to the way we've been writing equations? Obviously, the y equals mx and the y equals kx are the same, but here this has a b where this one does not. We find k by taking the y-coordinate divided by the x-coordinate that it's paired with. In a direct variation, usually as x increases, y would also increase, or if x decreases, y would also decrease. So, if we take a look at a direct variation, this is a direct variation, and we have a table of values. And so, think of these as, again, ordered pairs. And in a direct variation, we find k, or that constant, by taking the y divided by x that's paired with. So the k would equal, in this case, 12 divided by 6, which is 2. It could also equal 14 divided by 7, which is 2, or 16 divided by 8, which is also 2. Notice that the k stays constant to be 2. So then, when I write my equation in the form y equals kx, I have y equals 2x for this direct variation. Another example of a direct variation, again, if we have this, we find our k by taking the ordered pair, the y divided by the x. And since this is a fraction, I'm going to reduce top and bottom by 10, and I get 1/3. Well, if I do that with 5 divided by 15, divide both of those by 5, I also get 1/3. And if you notice that 3 divided by 9, that would also reduce to 1/3. So therefore, again, since k is equal to y divided by x, and k every time was 1/3, my equation would be y is equal to 1/3 times x. So now they're asking us, is this a direct variation? Well, to know if it's a direct variation, we have to make sure that every y divided by x is equal to the same constant k. So I take 6 divided by 4. Well, those both reduce by 2, which is 3/2. Or I could divide that out and get 1.5. Here, 12 divided by 8 is also 3/2, or 1.5. 18 divided by 12, both those divide by 6, that's 3/2, which again would be 1.5. And 27 over 18, both those divide by 9, which again would be 3/2. Since all these are the same, then this is a direct variation, and the equation would be y equals 3/2 times x, or you could have 1.5 times x. Now, is this a direct variation? Well, again, we have to see if is y divided by x equal to a constant k. So I have 5 divided by 15. Both those divide by 5 evenly. I get 1/3. Now I have to check 26 over 3. Well, I can see right away that that's not going to equal that. Since right away I have an ordered pair where it doesn't match, I know that this is not a direct variation. So, if we're given some values and we know that it is a direct variation, so we know that y varies directly as x, and we know that y is 28 when x is 7, they want us to find x when y is 52. Well, one way of doing this is to use our direct variation equation. And since we know y varies directly as x, we can find our constant k by taking y divided by x, which in this case k would equal 28 divided by 7, or k would equal 4. And if k is equal to 4, as we have right here, now we can write our equation, y equals kx, as y is equal to 4 times x. Now we go back to what they ask us to find. Find x when y is 52. So now we'll substitute in for y, 52, so I have 52 is equal to 4x, divide by 4, and x is equal to 13. And so therefore x is 13 when y is 52. In an application problem, we have the same type of thing. A car uses 8 gallons of gasoline to travel 290 miles. How much gasoline will the car use to travel 400 miles? Well, we identify which is going to be our x and which is going to be our y. And now we're going to find our k. So k in this case, if we're going to take miles over the gallons of gas, we're going to have k is equal to 290 divided by 8, which k in this case would then be 36.25. And so my equation is y equals 36.25 times x. Now, we want to find how much gas would be needed to go 400 miles. So we substitute that in for our y, and we solve, and we find that we need 11.03 gallons of gas. Now, this is a direct variation. This is one method of solving a direct variation, is using the direct variation equation. You could also use a proportion. So again, if we look back at what we've been doing, and again, we haven't talked a lot about slope-intercept form yet, but we have written equations in the y equals mx plus b form. In a direct variation, the equation is y equals k times x. So just like in the beginning, we talked about how these are similar, but this is a plus 0. So our k is the same thing as our slope, our rate of change, but our constant b is always 0, which means our graph must always go through, you're right, the origin. A direct variation graph will always pass through the origin. So, in this case, this is not a direct variation because it does not pass through the origin. This is a direct variation because it passes through the origin. This does represent the graph of a direct variation because it passes through the origin. Okay? And this one is not a direct variation because it does not pass through the origin. All right, and the last thing here is if we are given a graph and we want to be able to write an equation of this and find the constant variation, we first recognize that it passes through the origin, and it must pass through the origin for it to be a direct variation. And if it is, then I can get ordered pairs. So I have 1, 20, I have 2, 40, I'd have 3, 60, using those points right there. And if you've noticed, the k, if I take the y divided by x, would be the same every time, which would be 20. So in this case, using the variables that they're giving me, I would have a is equal to 20 times b. And if we look at this one, again, it passes through the origin. So I have ordered pairs of 100, 500, and so on. And I can just pick one point. If I know it's a direct variation, then I only have to pick one point. And I take the y divided by the x, and I get 5. And that's my k. So now I can write my equation as y is equal to 5 times x. Or in this case, E is equal to 5 times W. All right? That's direct variation. And be ready to practice this tomorrow in class. And we'll see you tomorrow. Have a great evening.
Made with Doodlecast Pro.